question 1, let's look at the key vocabulary word here. Rate of change is slope. And how do you find slope? Slope is rise, either rise up or down, and then you always run to the right. So what we're going to do is we're going to pick 2 points and we're going to do rise over run. Since this is a positive line, we're going to go up and to the right. So look at what we're counting by. On the y-axis right here, we're counting by 50s. So let's do that here. So we'll go from this point to this point. 50, 100, so my top number is 100. And then if you look on the x-axis, we're counting by ones. So you run to the right 1 time. So there's my slope. On this question here, if you just get to the key word, you have all of this stuff going on. But if you look right here, no more than. That means you can be equal to it, but you cannot be greater than. So you have to make the less than or equal. And to make the less than, remember like the little less than symbol kind of looks like an L. So let's find the one that has a less than or equal. So if you look, I can go ahead and cross out C and D. Now if we go into the problem, you can actually start looking at some of the information here. So let's see here. Baseball fans can buy tickets for seats in the lower deck or upper deck of the stadium. Tickets for the lower deck cost $42. So I'm going to say lower is $42. Ticket prices for the upper deck are 75%. So upper is equal to 75% of the cost of the lower deck. So you have to turn 0.75 or 75% into a decimal and multiply that times 42. But when you multiply something times 75%, the price is actually going to go down, because think about it, the lower deck, you're closer to the field, the tickets are going to cost more. So obviously the upper decks are going to be less. So let's see which variables go where. Which inequality represents all possible combinations of x, the number of tickets for the lower deck. So x represents the lower deck. I already know that this y has to be a lower price, so my answer is B. Now, you could actually take your calculator here and do 42 times 0.75, and you can confirm that the price of the upper deck tickets are $31.50. All right, let's look at 6 here. Which expression is equivalent? That's our key word. Equivalent means equal to. So here is what we're starting with, and then we're going to look at our answer choices and see if we can find a match. Now, I'll show you a little trick here what I do. If you look at your last number right here, notice the last number is positive 4. If you take the last 2 numbers in the answer choices and multiply them, -1 times 4, that's actually -4. So I know it's not F. And then look right here, take the last 2 numbers, 1 times -4, that's -4. This one is 1 times 4, I know that's positive 4, but that does not necessarily give me the answer. I'm just showing you a trick on how you can narrow some stuff down here. But what you have to do is, you have to come over here to letter H and do a multi-distribution. So let me clean this up here. So let's start here our multi-distribution. So we're going to start with the 2x. 2x times x is 2x squared. 2x times 4 is positive 8x. So now let's distribute the 1. That's going to be easy because 1 times anything is just what you're multiplying it by. 1 times x is 1x. And then look right here, 1 times 4 is 4. We have that number. Combine like terms in the middle. 2x squared plus 9x plus 4. So we know that h is not the answer, so our answer is J. Another thing you can do is, because the word equivalent means equal to, is that you can put this guy in y1, and you can put all of your answer choices in y2, and see if you can get a table that is equal to each other. Watch, I'll show you what I'm talking about here. So I have the problem in y1. Watch how I'm going to put, I'll just do the first one here. 2x minus 1, x plus 4. If I go to the table, notice that y1 and y2 do not match. And if you typed in each one of these answer choices into y2, you would not see a match. So our answer is J. All right, look at 6. Which statement is true about k of x equals? When I see k of x or r of x or t of x, f of x, I know that's y equals, so I'm going to use my y equals button to answer this question. And then my key vocabulary, if you look, is zeros. Zeros are the same thing as x-intercepts. Zeros, roots, solutions, x-intercepts, they're all the same. So I have an equation that's in y equals. Put it in y equals. We're going to graph it. And let's see which one has x-intercepts. You can see right here it crosses 1, 2, 3, 4 at -5 and 1, 2, +3. So let's find one that has x-intercepts at -5 and +3. If you look right here, my answer is G. 36, which table represents y as a function? So when we're talking about functions, I always give my kids love advice. I say, don't repeat your x, because if you do, your life will not function. So let's find the one that has x values that don't repeat, because we want to know which one is a function. So if I look right here, -5 and -5, those repeat, that is not a function. If I look right here at h, -3 and -3, those repeat. I don't care about the y's. We don't care about y or in love. We just care about our x's. All these 2's repeat, that is not a function. I have 6, -6, 8, and -8. Those are all different. Yes, that is a function. My answer is G. Only look at the x. We don't care about the y. 34, the graph of the quadratic function G is shown on the grid. So they're calling this graph just the G graph. The coordinates of the x-intercepts, y-intercept, and the vertex are integers. Integers are whole numbers. We're not creating any coordinates, we just want to pick a whole number here. And if you get down to what the question is asking, it's asking you what is the maximum. That is the highest point on the parabola here. So your highest point is located right here. And how far up in the y direction is the highest point located? It is located at 9. So what you would do is you would have your griddable, and then you would have certain sections on the griddable here. And then the first thing you want to do is it positive or negative? So we're going to say it's positive, so you would bubble in the little positive if you wanted to. You don't have to, but if you're kind of OCD and you want to bubble that in just to make sure that the Scantron knows that you're doing a positive value here. And then it doesn't matter where you put the whole number 9. I just usually just left justify it there. You'll go down here to 9 and bubble that in.